Hi, I'm Duncan from Enphase. I'm the Enphase Technical Trainer here in Melbourne. Now I've got a short video for you to talk you through a multi-phase installation using a solar subboard. So let's take a closer look and I'll talk you through each of the components in the wiring. Subboard installation allows for additional room for the fixtures and hardware required in a multi-phase installation. Here is the main isolator for the subboard. Adjacent is the power supply to the IQ gateway. The example uses a 6 amp 3-phase circuit breaker. Now each of the phases must be wired into the terminals of the IQ gateway. The gateway uses the phase connections as voltage reference for measuring the current transformers. An IQ gateway communicates by AC power line through the AC circuit wiring to Q relays and microinverters in an installation. This example uses a 25 amp RCBO, or you can also use a multi-phase 25 amp circuit breaker for each of the AC solar circuits. Each phase of the circuit is wired through to the multi-phase Q relay and connected to the grid terminals labelled on the Q relay. The Q relay is wired in series in line on each microinverter circuit. Now you may have one or a number of Q relays depending on the number of microinverters installed. Each phase of the solar AC circuit is wired into the PV terminal side. A current transformer, or CT, must be attached around each of the solar phases. Now each CT has a direction arrow. The direction arrow follows the current. So for this example, the arrow must face away from the solar back towards the circuit breaker or RCBO. Now it's very important that you have correct phase wiring for CTs. So it's worth marking or color coding each end of the CT flying lead so you can easily confirm that you have wired the correct phases across to the IQ gateway. It is always important to ensure that the phases are matched up correctly, along with the power supply phases connected to the IQ gateway. So for example, I have the red phase on terminal L1 of the IQ gateway, and I'm also measuring L1 for the production CT. Now white and blue phases, or line 2 and line 3, must also correspond correctly across the installation. And for each CT, the white conductor goes to the top row at the CT terminal of the IQ gateway, and the blue conductor always goes to the bottom row. The first 3 connections are for the solar production, then the next 3 connections on the terminal block are for consumption metering. Now always confirm you have wired into the correct terminals here. Often mistakes are made wiring these 3-phase consumption CTs. Be sure to confirm phase continuity and direction of the CT itself, as the consumption CTs will be located elsewhere, for instance connected around the main AC supply cable at the main switchboard of the site. So a good idea here is to label each end of the CT flying lead, and you can extend CT cables up to 200 meters wiring distance. This enables you to have a lot of flexibility with your installation of the IQ gateway. Now this is a nice working example of how you can complete your configuration for a multi-phase site. So to help your installation, you can see here we're using a 36 pole enclosure which allows enough space to put 3 200 amp CTs for solar production within the same board, and you'll notice that the IQ gateway and the circuit breakers all fit well within this space. Now the example I'm showing you is a manufacturer pre-made solar subboard. You'll be able to source these from your solar supplier, so ask them for further details.